Welcome to the DIY Honda Garage channel. The DTC P0139 indicates an issue related to the secondary heated oxygen sensor, specifically labeled as secondary HO2S, sensor 2. This sensor plays a critical role in monitoring the oxygen content in the exhaust gases after combustion, ensuring optimal air-fuel mixture for efficient engine performance and emissions control. Located in the exhaust system, specifically downstream of the catalytic converter, the secondary HO2S is vital for the engine control module's ECM calibration adjustments. When this sensor's output voltage does not change as expected during feedback control processes, the powertrain control module, PCM, interprets this as an anomaly, consequently triggering the DTC P0139. The importance of a properly functioning secondary HO2S cannot be overstated, as malfunctions can lead not only to decreased fuel efficiency, but also to elevated emissions, affecting environmental compliance. Thus, diagnosing and addressing this fault is essential for maintaining vehicle performance and adhering to regulatory standards. The error associated with DTC P0139 involves the secondary heated oxygen sensor, designated as sensor 2. This sensor is crucial for monitoring exhaust oxygen levels post-combustion, allowing the engine management system to adjust for optimal fuel efficiency and emissions reduction. It is positioned downstream of the catalytic converter within the exhaust system, a location chosen to gauge the effectiveness of the catalytic converter in purifying exhaust gases. If the voltage output from this sensor remains constant and does not fluctuate during the stoichiometric feedback control process, the PCM perceives it as a malfunction. Such a malfunction may contribute to poor engine performance, inefficient fuel combustion, and increased emissions. Essentially, the secondary sensor aids the PCM in adjusting the air-fuel ratio, ensuring that the engine runs at peak efficiency, making its proper function vital not only for performance, but also for environmental compliance. Several factors can trigger the DTC P0139. Firstly, a faulty secondary heated oxygen sensor may exhibit slow response characteristics, leading the PCM to recognize a fault condition. Secondly, leaks in the exhaust system can create discrepancies in the sensor readings, causing the PCM to misinterpret the data it receives. This scenario underscores the need for thorough inspection of the exhaust pipes and related components for any signs of damage. Additionally, wiring issues, such as frayed wiring or poor connections to the sensor, can result in incorrect voltage readings, triggering the sensor's slow response DTC. Each component plays an interconnected role, and diagnosing these potential causes is essential for resolving the error effectively. Addressing these various issues can restore proper sensor function and ensure accurate emissions monitoring. Symptoms associated with DTC P0139 often include the illumination of the check engine light, CEL, on the dashboard. This warning signifies that the powertrain management system has detected a fault, prompting the need for diagnostics. Additionally, drivers may observe a decrease in fuel efficiency due to the engine not operating optimally, resulting from the faulty readings provided by the secondary HO2S. This inefficiency can lead to increased fuel consumption, impacting overall vehicle performance. Furthermore, as the secondary HO2S is linked directly to emissions regulation, issues with this sensor may lead to elevated emissions, contributing to possible failures in emissions testing. Recognizing these symptoms early facilitates timely intervention and maintenance, ultimately preserving both the environment and the vehicle's performance. Commencing the troubleshooting process begins with starting the engine to check the immediate operational status. Once the engine is running, it is important to hold the engine speed at approximately 3,000 revolutions per minute, RPM. without any load, ensuring the vehicle is in park, P, or neutral. This step is crucial because it allows the engine to reach a specific operational temperature, which is necessary for accurate readings from the sensors. Observing the radiator fan's activation during this period is also essential, as its function indicates that the engine is reaching the required temperature threshold. Ensuring that the fan operates correctly during this step helps set the stage for subsequent diagnostics. If the fan fails to engage within a reasonable time frame, further investigation into the cooling system may be necessary. Following the engine warm-up and verification of the radiator fan operation, the next step is to allow the engine to idle. After idling for a duration, it's crucial to test drive the vehicle while carefully monitoring specific conditions. The desired state is to have engine coolant temperature, ECT sensor 1, reading above 158 degrees Fahrenheit, 70 degrees Celsius. Once this criterion is achieved, the transmission should be placed in drive. D. To simulate normal driving conditions. During this test drive, it's essential to maintain a steady speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour, for at least 1 minute. After sustaining this speed, decelerate gradually while ensuring the throttle is completely closed for a minimum of 10 seconds. These driving conditions provide the optimal environment for the PCM to gather accurate data from the secondary HO2S. Setting the groundwork for effective diagnostics. The final step in the troubleshooting process involves monitoring the Honda Diagnostic System, HDS, for any updates regarding the OBD onboard diagnostics status. It's essential to verify the system's recorded information to confirm any ongoing fault codes, particularly DTC P0139. By checking the OBD status, technicians can determine whether the previously stored DTC still persists after performing the idling and driving procedures. Using the HDS allows for an integrated view of system performance, indicating if the secondary HO2S is functioning as intended. If the DTC remains active, it indicates that further interventions, such as inspecting the wiring or replacing the secondary HO2S, will be necessary to resolve the issue. Monitoring this status is imperative, as identifying a recurring fault ensures attention can be directed toward enough diagnostics and subsequent repairs. After addressing the issues associated with DTC P0139, it's vital to verify that repairs were successful. This step begins by clearing any DTCs from the Honda Diagnostic System, HDS. Once the DTCs are cleared, the vehicle must undergo a test drive to assess whether the problem has been fully resolved. During this test drive, it's essential to recreate the previous driving conditions to ensure that the secondary HO2S can be accurately monitored under normal operating scenarios. After the drive, recheck the HDS for any reoccurring DTCs. If DTC P0139 or any other faults are absent, it signifies that the repairs were successful and that the vehicle is now functioning within expected parameters. Ultimately, this verification phase is crucial in confirming the reliability of all repairs performed. Preventive maintenance plays an essential role in avoiding future occurrences of DTC P0139. Conducting regular inspections of the secondary heated oxygen sensor and related components can help identify issues before they escalate into faults. Checking the integrity of the exhaust system for any leaks is particularly important, as even minor leaks can provide skewed readings from the oxygen sensor. Addressing such leaks proactively ensures that the sensor functions reliably. Additionally, closely monitoring fuel efficiency and emissions can act as early indicators of potential problems. Early detection leads to more effective diagnostics and repairs, thereby minimizing downtime and preventing costly repairs in the future. By committing to a regular maintenance schedule, vehicle owners can enhance performance and fuel economy while ensuring compliance with emissions regulations. In conclusion, understanding DTC P0139 and its implications is crucial for Honda CR-V owners and technicians alike. Recognizing that this code pertains to the secondary heated oxygen sensor's slow response highlights the importance of monitoring exhaust gas conditions for optimal vehicle performance. Following the defined troubleshooting steps provides a systematic approach to diagnosing the issue and identifying corrective actions. By addressing potential causes such as a faulty sensor or exhaust leaks, technicians can restore functionality and ensure compliance with regulatory standards. Lastly, committing to preventive maintenance can prevent similar issues from occurring in the future, protecting both the vehicle's performance and the environment. Overall, a proactive and informed approach leads not only to efficient repairs, but also to sustainable vehicle operation. Please like and subscribe to the channel. See you next time.